Okay, so part A here on number 1, just about everyone got. The first thing you had to do was find this point of intersection. So you had to graph these, find that point of intersection, and then use that x value for your integral. So the first part, just about everyone got. That was fine. Part B gave people a little bit more difficulty. On this one, you're rotating this about y equals 1. A few of you guys did x equals 1 or kind of thought of it as x equals 1. But here's y equals 1 right here. And if you're going about y equals 1, then the shape is kind of got this 3D kind of bundt cake looking thing. And you're going to use the washer method, because the shell method you'll not have to use at all on this exam. And so in order to use the washer method, you've got to think about the various radii. And you will integrate from this x value, well, let's see, one washer, the big radius is going to be this y value, y equals 1, minus this y value. So the difference from y equals 1 down to there. And what that's going to be is 1 minus e to the negative 3x. The little radius is going to be the big y value, which is y equals 1. Y equals 1 minus the smaller y value, this little stretch right here. So it's going to be this y value, which is 1, minus that y value, which is root x. So that'll be 1 minus root x. And for the washer method, you're going to integrate from the x value, which is 0.238, 2.2387, up to 1, and it's going to be the big radius squared. And actually, if you've already defined r and r, well, actually, r was already defined here, so maybe we call this r1 and r sub 2. This will be r sub 1 squared minus r sub little r sub 1 squared, and then times the thickness of this, which is dx. Yeah, so that's it. And then part C, just about everyone got this or was close to it, and I made notes on your page if you didn't get it for that one. All right, so here is number 2. Let's see. The first one, some people tried to figure out they knew that it had to do something with the antiderivative of this. Some people try to find that antiderivative for part A, finding the x-coordinate at position t equals 4. Well, we know that x of 2, from the given, x of 2, the position at time at 2 is 1. And this is a fundamental theorem of calculus problem, part A. You do have your calculator. This function here does not have an antiderivative. You can't anti-differentiate that. Try as you will, no one can do that. But what we can do is a calculator can figure out a definite integral involved in that. So if you think about the integral of that x prime of t taken from 2 to 4, x prime of t dt, that's going to equal x of 4 minus x of 2 by the fundamental theorem. Therefore, x of 4, which is what they want us to find, is going to equal x of 2 plus the integral from 2 to 4 of x prime of t dt. Another way of thinking about it is that this is the displacement that x has from t equals 2 to t equals 4. So you take its position at 2 and you add the displacement that it had, that x had from 2 to 4, and that will give you the position at t equals 4. Okay, part B and part C, most people got. If you didn't, look at the scoring guidelines, and that hopefully will clear things up. Part D, people had some problems with. So you're given this here, dx dt, and you're told that dy dx, you're told the slope is 2x plus 1, and the slope is dy dx. So dy dx equals 2t plus 1. But we also know that this is equal to dy dt over dx dt. And we also know that dx dt from our given is equal to 3 plus cosine of t squared. So therefore, with a little multiplication, since this is equal to this, then dy dt is equal to 2t plus 1 times 3 plus the cosine of t squared. 3 plus the cosine of t squared. So there it is. There is the first part they asked. They asked for the what did they ask for? No, that's it. They didn't ask for that explicitly. But you did have to find that explicitly. Because in order to find the acceleration vector, what the acceleration vector is, it's the vector x double prime of t, comma, y double prime of t. So there's your acceleration vector, and we want to find this specifically at t equals 4. So we want x double prime of 4, comma, y double prime of 4. And the easiest way to find this is you can actually take the derivative of this with respect to time and this with respect to time by hand, and some people chose to do that, but that took a bit of time. This one's not so bad to do this one by hand. This one is a bit of a bear because you have to use the product rule and a bunch of chain rules, and it gets a little complicated. But the easiest thing probably to do is to use your calculator and do the derivative of the point, and take the derivative of this at 4, and take the derivative of this at 4. And when you do that, you will get the answer. You'll get that the x double prime of 4 is 2.03, excuse me, 2.303, and the y double prime of 4 is 24.813. So use your calculator. You've got it. Don't try to do too much by hand. You can, but at the same time, you could be wasting your time doing that. Okay, so for number 3, most people were pretty close on most of the parts of this problem. Part A, you had to differentiate with respect to y. They wanted dx dy, so just take the derivative of both sides with respect to y. The derivative of x with respect to y is dx dy, and on the other side, you take the derivative of the square root of 1 plus y squared with respect to y, and it will work right out. So, and then you plug in, but you'll have it in terms of y, and you plug in that y value you got, which was, everyone did get, y was 3/4 at the point of intersection. For part B, what you have to realize is that you have to integrate with respect to y, because if you slice it this way, the problem is your heights change. You've got one height here, and then you've got another height here. So it's much easier if you integrate with respect to y, that you're always you got dy is the height of the rectangle, but the width of the rectangle is this x value minus this x value. And most people got that, and that was all right. C, every single person got. And D, some of you guys forgot the formula, that it's 1/2 r squared d theta. And other people messed up finding the upper bound. They knew it was from 0, the upper bound of theta. The question is, what to put up here? What is this going to be? Well, the key thing is you want to figure out what angle, this is a line here, and what angle is this line at? And you can figure out that this rise to run, the ratio of that y to the x, is going to tell you, if you know the ratio of this to this, you can then use inverse tan of basically the slope of that line. And the slope of that line will be 3/5. And so that is that's the trick there. They actually gave you that as well, because you know that was x equals 5/3 y is the equation for that line. So the inverse tan of 3/5 will give you this angle right here, and that will be the angle that you have to sweep out to. So you're sweeping out these various areas here. So that's what's going on 3. So question 4, there were a couple problems where people had some issues. One was part A, figuring out where the function f is increasing. And we're looking at f prime here. And most people knew that if f was increasing, if f was increasing, then f prime had to be greater than 0. And so they knew it was on this stretch from -3 to -2, and people found that interval. Describing it was a trickier thing. So some people said, oh, it's increasing because it's positive, or the function is positive. Be specific. Why is it f increasing? Because f prime is greater than 0. Be specific. Name the function specifically, what you're talking about. So use terms like f prime, f double prime. Those things are really useful, and don't use it. Don't leave it vague, because you will lose justification points, even though someone can read into it and be like, I think they know what they're talking about. No, yet they have to know that you know what you're talking about. So for part B, finding the points of inflection. So people were pretty good about identifying the 2 points of inflection. One of them is at x equals 0, and one is at x equals 2. One or two people did not think that 0 would be it because they didn't think that f double prime was defined. That's okay. F double prime does not have to equal 0. It can be 0 or undefined. The key thing for a point of inflection is that there has to be a change in concavity of the original graph. And if there's a change in concavity, then f double prime switches from positive to negative, or vice versa. Okay, so you have to talk about f double prime switching. Some people did talk about f prime just by itself and said f prime goes from decreasing to increasing, or decreasing to increasing, or increasing to decreasing, which is saying the same thing as this, and either one of those is acceptable. So you can either talk about, to justify points of inflection, you can either talk about f prime, points of inflection of f. You can either talk about f prime going from increasing to decreasing, or decreasing to increasing, or f double prime switching signs, going from positive to negative or negative to positive. And that happens when f double prime is either 0 or f double prime is undefined. So part D gave people by far the most trouble, probably out of any question on this exam. Okay, so part D was asking you to find f of -3 and f of 4. Given this graph and given one other fact, you're given that, let me look at the problem. Oh, f of 0 equaled 3. Okay, now we're looking at f prime. And so what you want to use on this problem is the fundamental theorem of calculus. You can look at it a couple different ways, but it does come down to a fundamental theorem of calculus problem. So probably the easiest way of thinking about it, this is one way, there's many ways of thinking about it, but you can think about the integral. So I know f of 0 is 3, and I want to find, let's say, f of -3. So I know that the integral from -3 to 0 of f prime of x dx would be equal to f of 0 minus f of -3. And we do know f of 0. We know f of 0 is 3. We also know this integral, the integral here, and what that's going to equal, well, it's the net area change. So it's this integral right here, from -3 to 0. This area here is a half, and this area here is -2. So the integral from -3 to 0 is going to be 1/2 minus 2, which is equal to -3/2. So -3/2 is equal to 3 minus f of -3. And if you rearrange this, you find that f of -3 is equal to 3 plus 3/2, which is 4.5 or 9/2. Another way of thinking about it, about this f of -3, is that the net change here of f from -3 to 0 is down 1.5. And so if you think about it, at 0, the y value of f was 3. And in that time period, it had gone down 1.5. So where was it? You kind of rewind the time. You think about dx going backwards. Well, if it had gone down 1.5, then it must have been at 4.5 at -3. So that's one way of thinking about it. It's hard to write that down and express that in equations. And so going with the fundamental theorem of calculus is probably your easiest thing to do. Okay, so for finding f of 4, again, we can think about the integral from 0 to 4. And if the integral from 0 to 4 is going to be this shaded region right here. So what is that shaded region? Well, to get that, you can figure out the area of this rectangle, which is a 4 by 2 rectangle. So that's 8 minus the area of this semicircle. And this is a circle with radius 2. So the full circle would have an area of 4 pi. So that's half a circle, so it must be 2 pi. So this area here is 8 minus 2 pi. However, since it's below the axis, if I were to integrate with a positive dx and find this area, dx would be positive, y is negative, so that integral from 0 to 4 of f prime of x dx would equal -8 plus 2 pi. And that's going to equal, as well, by the fundamental theorem of calculus, f of 4 minus f of 0. And again, we know f of 0. We know that's 3, so if you move that over to this other side, you find that f of 4 must equal f of 0 plus the integral from 0 to 4 of f prime dx, and that's going to be 3 plus the quantity -8 plus 2 pi. So that's where the answer of -5 plus 2 pi comes from. Again, but you can look at this, just like the last one, that f of 4 is going to equal the y value of f at 0 plus the displacement that f had from 0 to 4. So it was at x equals 0, f was 3, but then it changed -8 plus 2 pi. So you end up with -5 plus 2 pi as the position at t equals 4. Again, the fundamental theorem of calculus is going to come up in a lot of times in different ways, but it helps just to write it out and plug in what you know to be true. Okay, I'm not going to talk about 5 too much because people were pretty good about getting this one. I wrote pretty good notes, I think, on what a lot of you guys did wrong, and the scoring guidelines should give you a really good idea of what to do on this problem. Pretty self-explanatory. The key that one or two of you guys missed, I think maybe 2, is you forgot to separate the variables on part B, or you didn't see to separate the variables. But the key is getting to the step of dh over root h is equal to -1/5 dt, and then integrate from there. Integrate both sides. Don't forget your plus c, and people are good about doing that. So lots of little algebra mistakes cost people the 5th point, because people are good about taking the antiderivative here. People are good about doing the plus, putting the plus c. People are good about plugging in the initial value. But there was a point for solving for h, and that is where some of you guys went wrong. And but you got 4 of the 5 points for doing a lot of calculus correct. And then if you properly used your answer from part B to get part C by plugging in 0 for h, then that was good. That worked. So that's pretty much it for 5. Okay, so 6, well, I don't know, how did 6 go? 6, yeah, I mean, some people might have been running out of steam a little bit on this one. But for part A, most people got, but some of you guys got parts of it, but not the whole thing. And if you want to find f prime of 0, you didn't have to start by trying to figure out what this function was. You wanted to start by just playing around with it a little bit. So you've got this nice power series here, this nice Taylor series looking thing. And you want to find f prime of 0. Well, this is f of x, so what's f prime of x? And I would just start by taking some derivatives of this actual thing. So f prime would be 0 and then minus 2x over 3 factorial plus 4x cubed over 5 factorial minus 6x to the 5th over 7 factorial plus dot dot dot. And if you plug in 0 into this, you find that f prime of 0 equals 0. So it's a candidate for a min or max. But what will tell us, well, what you really want to do is they tell you to find the second derivative because they want you to use that to find whether it's a min or max. And if you take another derivative, you get negative 2 over 3 factorial plus, what is this, 12x squared over 5 factorial minus 30x to the 4th over 7 factorial plus dot dot dot. And if you find f double prime of 0, you're going to end up with negative 2 over 3 factorial, which is also known as negative 1/3. So that tells you that at 0, the slope is 0, and the second derivative is negative 1/3, which is negative, which tells you the graph is concave down, which means that that thing must be a maximum. And so you have to use, this is using the second derivative test to figure out whether it is a min or max. So looking at when the first derivative is 0 and looking at when the second derivative is either positive or negative, and that's going to be your indication. Part B, a lot of you got. Some people use kind of some bad notation, which may or may not have gotten you the point. It depends on how generous the reader was. But I think if you knew to look at the third term and plugging in 1 into that gives you 1 over 120, and 1 over 120 is less than 1 over 100. So that's what they wanted. But that was only worth a point. Then there is part C. So part C. So for part C, you can use, look at the scoring guidelines. They walk through 2 different ways of doing it. One way is just playing around with the series. You found y prime in part A, so use the series you found in part A for y prime, and then you multiply it by x, and then you literally add it to what the original function was. And if you look at that series, and simplify the like terms, you end up with 1 minus 2 factorial over times x squared plus 1 over 4 factorial times x to the 4th, and then minus 1 over 6 factorial x to the 6th, and you should be like, oh, well, wait a minute. That is the cosine of x. So that's one way of doing it. Another way of doing it is to recognize that this right here is the product rules happened already. So this is just x times y prime is equal to cos of x, which tells you that x times y has to equal sine of x plus c. And some people put the c there, some omitted it. I think you're okay if you omitted it. I didn't take off for that. But you can say that, okay, well, if we plug in 0, it's going to be 0. Both sides will be 0, so c must be 0. And then from here, some people concluded that y must be sine of x over x, which it kind of is. It is everywhere except at 0. This is one of those things that we had a problem in the book like this, where y would actually have to equal sine of x over x, except at x not equal to 0, and at x equals 0, then it would be 1, and that would keep it continuous. Because this does exist at 0, the limit as x goes to 0 is going to be this 1 right here. And sure enough, that is sine of x over x. And some people then looked at this and said, wait a minute, this works because if we take this series here and we multiply it by x, well, this will become 2x plus 1, and that is the sine series. So x times y is indeed sine of x. So some people kind of played around with that way. One person in our class, in one of the classes, I can't remember who it was, but they noticed that, they figured out kind of that process that y was equal to sine of x over x. And then they figured out, well, if that's true, then y prime will be x cosine of x minus the sine of x, which simplifies to, over x squared, which simplifies to cos of x over x minus the sine of x over x squared. And then they said, okay, well, that y prime will equal the cos of x minus the sine of x over x. And if we add that to y, and y being the sine of x over x, then these cancel out, and you get cos of x, which is what they wanted us to prove. So that was pretty good and clever, and that, I think, I gave you 4 points, and I think the reader would too, because that was showing some pretty good thought. So there are the common mistakes on the free response. Hope this is helpful.